Hello everyone, we are live. So soon we will know what this evening will be about. And there we close the voting, and this is the result, everyone. Every alternative is relatively spread out, but there is a huge majority for this fetch library for C. So let's see if we can accomplish that. It would be a rather ambitious project, even if we were to be allowed to have those libraries, but I'm sure we'll figure it out. And before we start, I want to show you the repo. Not everything is available unless you're a member, but some things are. And I will be using my own library, BirchUtils, which has a couple of functions that I basically use in every project. I will also be using this bash bs, which is my new build system. I made an episode of it like a week ago, and it basically creates a new C project from a template, so I don't have to rewrite the exact same code every time. And there's also a couple of our other stuff here at repo.drbert.com. And when I publish the recording of this live stream in a couple of days, I will also publish the code, and it will be online for 48 hours for everyone to get. So what I will do is I will go to my server. Let's code it on this one, and I will create a new folder. And what should we call this one? It's our own fetch library for C. C fetch, it's a little bit boring. Grab, that's good. Let's call it grab. So I will have created an empty folder. I will just right click and open an editor. And hopefully I will get this into my local VS Code, which I need to change size for so you can see everything. Let's minimize this and position this like so. And let's minimize the shot. Alright, so now I have my empty folder right here in VS Code. And let's see. Let's do this instead. I will go into this server. I will be coding in VS Code, and I will be coding against a Linux machine. Let's see, keep that one. I'm trying, if you wonder what this is, I'm currently compiling, or I think I was compiling. No, I am. The new version of GCC. Because I want to try out some of the new C23 features. But that's not interesting for this project. So let's see. I'll go into code and see, and here is my grab folder. Let's see, do I have bash bs installed here? I don't. So in this case, I will create those files from scratch because I haven't the build system installed on this machine, but that's okay. Maybe it's even positive, since this will be a rather different project than everything else, since I will not be able to use any libraries and such. So I have gone into this directory. Let's create the files and see that everything is working, because it's a remote server and it should sync against this one. So let's create a grab.c and let's just put some header for now. Grab.c, like so. And I hope you are able to see this. I know you're not able to see the top of the window, but that's by design. I want to be able to use as much room as possible on the screen for the actual coding editor part. But you should be able to see at least all of this part. So I need to make it a little bit smaller, I guess. So let's see, something like this, and perhaps even like this. Alright, so we save this one. I will create an additional grab.h. And I will speed through this part a little bit because it's basically boilerplate stuff. And let's see if it updated correctly. Yes, it did. So now my files are on the server, and every time I save or create a directory and so on, it will automatically sync my files. Okie dokes. So let's start by, I was almost saying include a lot of things, but we will not be doing that since we will not be using a lot of things. However, we will be using system calls, so there will be a couple of includes, but that's not libraries. Alright, so let's see. I will create a couple of integer types, as I usually do. I want to have an unsigned int, which we will call, unsigned char, which will be int 8. I will have an unsigned int, which is int 32. In between, I will have an unsigned short int, which will be int 16. And I will also have an unsigned long int, which is int 64. I do also like to create those aliases or macros for my typecasting. So basically, if I need to typecast something into char, which happens rather a lot since I'm using my own types, then I will call this $C. So that will cast it into char. And then I will have an $8, which will cast into an int 8 pointer. And I will have a couple of those, just to make it easier to handle those conversions, which happens rather a lot. And I will also have a 4 for int 64. Did we get all? We have 8, 16, 32. Oh no, let's see. 2 should be in 32. And then I will have one which will convert back to regular int, like this. So basically, if I were to create an int 16 FD, for example, and I wanted to open a file descriptor to a file, I would do something like FD equals the int 16 of open, and then I will send a string, and then I will have some variable, let's say file name, and that file name is an int 8 pointer, and then something like O read only or whatever. So this is how my dollar, sorry, this is how my dollar macros are being used. They can look quite confusing unless I take the time to explain that. Sorry, I need to drink a couple sips of water. All right, that's better. So we have those definitions, and by the way, while I am developing, I usually, even if I'm not allowed to use any libraries when the code is complete, during the development, I would like to have the ability to use printf. One thing I could do is I could use my own printf library, but I don't want to upload and do all that stuff. But a lot of you have probably seen it, so you know that I have coded my own printf library, and I will not use this in the production code, so to speak. I will only use it during development as a debugging mechanism. What do you say, guys? Is that, let's see where I put you here. Do you think that's cheating, or is it okay? It's pretty fine. All right, that's great. Then I will continue using those printfs for development. We can even go as far. Let's see, if we were to, what was I? Let's see. Let's say we have some kind of definition, debug, and then perhaps down here we were to have some kind of if defined debug, then, or maybe we could do this, if not defined debug, then we will define printf. Let's see, something like this. And I'm not sure if this is possible, but maybe something like this. No libraries allowed. Probably it will not work with the error thing, but let's try it at least. We don't learn stuff if we don't try stuff, right? And that's right. We also need a Makefile, by the way. So let's create that. Include grab.h. And I will just speed through this Makefile part because I don't want to use up all the time on different preparations. If there is something that you do not understand in this Makefile, please ask it in the chat, and Arnab will relay that question to me when I take a break for looking at the chat the next time. So we will use the standard C2X since I haven't compiled GCC, the latest 14 version yet. We might have some LD flags, but probably not. Or maybe we will use my own Birch Utils library, by the way. what else? Let's create grab.o, which relies on grab.c and grab.h. When this occurs, we will run cc with flags -c and the first source. Then when we have the grab.o, we can create grab, and we run cc with the flags, and we take the source file, output the target file, and put perhaps some ld flags as well. And our all will run clean, and it will run grab. And clean will simply be something like removing all the .o files and the grab binary. And since those two options, the all and the clean, is not something which produces anything, we will mark them as phony. And this is the whole thing, I think. Let's see if it compiles. Yes, it does not find LBU, but I think maybe I call it birch duties. Let's see. If you want to find a library, at least I usually do like this. I run LDD on some dynamically linked executable like ls, and then I just copy this library directory, because it used to be always in /lib or possibly in /userlib, but nowadays they hide away those libraries and the include files as well in odd directories, which are very hard to anticipate. Alright, so let's ls this directory and see if we have something with a bu. Okay, that was quite a few. Libbu, nope, and libbirch. So I don't have that installed. Alright, I do think I have it somewhere. Right, I have it inside of the runlock project, that's why. So let's go into, where is it? Birch is here. Okay, so here it is. We can just do this then. If you want to install a library manually, you need to first figure out where to store the include files. If I remember correctly, in my case, it's just user include. And you copy the H file. Then you take this .so file and you copy it to the directory that we found earlier. And you need to name it something that begins in lib. And in my case, I want bu, and then the extension .so. And when you have copied everything, you just run ld-config. And now everything should be in order. Let's go into the C file, or the H file rather, and include that library. And this is my own library that I wrote in a earlier video episode. So this is according to the rules, everyone. Alright, so birch util, and it doesn't contain much. I can show you, it's only like 3 functions or something. Let's see, if I open user include birch utils, you see that I have I have this ns2h function, which is basically the opposite of h-ton-s. And that's the function which puts a port number in network byte order so it can be used on the network. Then I have a print hex function. I have two dotted, which takes an IP address in a number format in the network byte order and creates a regular IP address with the dots and the numbers, you know. And then I have a zero function, which basically takes a variable and zeroes it out completely. Alright, so let's see if it compiles. And what does it say? Undefined reference to main. That was what we were looking for. So everything works except it can't find the main function, which is rather self-explained since we don't have a main function. But let's create one. And I'm not sure if I should have, I should probably send arguments to this one. No, I don't think I will. I don't think we even will have a main function. We will only have it during development so we can debug stuff. But since we are building a library, we will just make an SO file out of it, which will be linked to other C projects. So let's return 0, and this time everything should be compiled. Okay, so everything is up and running. So let's think a little bit about this. A fetch library for C. Maybe I could, let's open the text edit. I think that's a rather good choice. We'll create a new one. And right here, little tiny text perhaps. I hope you can read this one. If you can't, please tell me, and I will do what I can to take care of that. Okay, so we are writing a fetch library for C. And most of you probably know what that means, but since not everyone knows it, I will just talk a little bit about fetch. So fetch is a JavaScript function which basically works like this. So you run fetch against some link like this. Maybe this should be a little bit bigger. Like so. And this will create an outgoing HTTP client connection towards that URL. And then you will tell fetch what to do. There is a couple of different ways to do that. Some use this then method, but the more common nowadays, I would say, is you create a variable and you do something like x equals, and then there's this keyword, because fetch is a function which does things not right away, but after a while. So it's an async function, which means we have to wait until it is done. And you can specify that in JavaScript by the await keyword. So this will halt execution of this specific function until this fetch is complete. And then you can do some sanity check, see if X really returned anything. And then you, depending on what you need to do, you can, for example, let it download a file and then you handle it by referencing X. Or more commonly, this is some kind of JSON data. And then you do XJSON, I think it is. And then you extract the JSON data from this thing. And this is also an async operation. And then you can just do, let's say we have a y. And we set y equal to, we set y equal to this. And now, if we, for example, have an object inside of that JSON, which is called ABC, and we can just access that by doing y.abc. So this is what we want to accomplish. And since fetch is a rather big thing, it can handle a lot of different files. Maybe we should constrain the project to begin with, so we focus on one specific task, and when that is done, we can continue adding features. So let's do this in different steps. First, we need to code the ecosystem of utility functions and stuff. Since we don't have any access to the libraries, we need to create a lot of small functions which does specific tasks. Then we want to code the network connection. So we can do an outgoing HTTP request and interpret the results. Maybe we should put that as well. Interpret the results. And these results we need to put in some kind of data structure. So maybe we should do this as 3, this is 2, and first we define our data types. And it remains to be seen what kind of data types and structures we need, but at least we will need something like a response object. That's what it's called in JavaScript at least, and we will have something similar. So this will basically be some kind of a structure that will hold all the different parts, like the HTTP code, like 404 and similar. And it will, maybe we should write this up. So, what's it called? Status code. HTTP status code, I think it's called. And this is not an exhaustive list, I will just add a couple of things. So it will contain that. It will also have the headers of the response and possibly any cookies. And what else? The data, which will be either like a, what can it be? It can be a HTTP post body, for example, or if it's a GET request, it will simply be a file, and so on and so forth, and a lot of different other things. But this is a very important step, since this is what will be a part of our API, because we are creating a library, right? Which means we will have a lot of different functions which will do stuff under the hood, but a programmer is going to use our library when he develops his stuff, and we need to interface with him somehow. So that's why we will have a couple of objects or structures that we will present to the programmer. And this response object is one of the most important. Perhaps this will even be the only thing we will have, because it will probably contain everything else. Almost everything else. And then we will also have a couple of functions which you will use, where the most important, of course, is the fetch function itself. But there might be a couple of different steps relating to this. We will also, let's leave it at that for now. Then we code the utility functions, we code the network connections, and when we have gotten this to work, we can make those a little bit more advanced things, like a JSON library. We need to create our own. It's no super easy task. We will also need something like, what's it called? Concurrency. Because we need to make fetch an async operation. At least our goal is to make it an async operation, right? So it won't freeze your entire project while it will do what needs to be done. And we need to develop this ourselves from scratch, because there is no thing in the kernel we can just say this should be concurrent. There are threads and there are forks and stuff like that, but we need to put it all together somehow. And then maybe we can add other stuff later on. I think this is a rather sensible plan. Yeah. First line is not visible. Is that inside of this code or in the terminal, or probably here, right? Good. Thank you, Husam, for mentioning that. There is nothing more annoying than watching something and don't see all of it, right? So I think I need to make this a little tiny bit smaller. Something like this, right? Okie dokes. And Arnav, I don't think we will reach the fifth point today, but I think we should have like a goal at least of when we finish this project, we have written our own JSON library. But I am totally on your track. I don't think. I think the JSON library on its own is probably almost as big as the rest of this project, so we will not be coding a JSON library today. All right, so according to this plan, we should start by defining our data types, and I think that's a good general strategy when developing software, no matter what language or what type of software. And especially Haskell programmers are very used to that way of working, because Haskell has a very expressive type system. But we can do quite a lot with C as well. When it comes to the type system, I mean, and everything else. All right, let's create the function signature before we continue, so I don't forget. Okay, data types. What do we need? We need the response object, right? Which should be based on a structure which we'll call sResponse. And what should this contain? Well, I think we should have a general thought in our heads, like, so we think the same way we did when we were coding on our web backend API. It doesn't have to be compatible or anything or even look the same, but at least the general sense, I think, was a good way of thinking. So basically we will have our own headers data type. We will have a pointer to the headers, and this is the data type. We will define it soon. And we will also have a similar thing for the cookies. When it comes to the status code, we can just have an int 8 for that. Or is it enough? No, it's not. We need to have at least 16 bits. So let's make it an int 16 status. Alright. So we have the status code, we have the headers and the cookies. What else did we say? Maybe we should create one specific thing for the content type, because that will be very useful for us ourselves when coding this thing. So at least for now, let's put the content type in its own. So we have this and we have that. What else did we say? Well, the data itself, that too should be included in the response. And how shall we store the data? The data can be basically anything, right? It can be the query response to some HTTP query. It could be JSON data or a Windows exe file. A lot of different things. So let's make it as general as possible. All we will define is that we will manage it byte by byte. So let's make it an int 8. And let's just make it a pointer like this. And then we can allocate on the heap for this. And since we are allocating on the heap, we also need the size of this. And not specifically because we are allocating it on the heap, but because that is how it's usually handled. Right, we don't have malloc, do we? That's a little bit interesting. We can't allocate dynamic memory at this point, because malloc is not a system call, it is a libc library call. But I think we can work around that, so let's keep it like this. And let's have an int 32, is that enough for the size? But I am thinking, what if we were to download some file bigger than 4.3 gigabyte? Would that be possible with an int 32? No, it will not. So this needs to be an int 64 if we want this to work. Okay. So this is what we had this far. Maybe we should put a cap on this for now. So let's develop these things, and if we need anything in addition to that, we will do that after. And I will also end this struct, and I will do a type definition struct s response, and we'll call it response with a capital S, TypeScript style. What else? We will need those two, right? Headers and cookies. So we will create a struct which is called s header. And what do we need inside of this thing? A header basically looks it looks like this. So it has two parts. It has this, I don't know what to call it, a key perhaps, and then it has the contents of that header. So let's make this a int8 array, I think. So how big does this needs to be? Let's call it key. And the HTTP standard most definitely defines the maximum length of this one. I don't know that at this point, and I don't want to spend time looking it up. If anyone in the chat knows or knows where to find it, please do. But for the time being, at least, I will put this at 64 bytes. And add a comment so I don't forget. What about the other part of it? That could be rather big, I think. Let's also make this an int8 array, but let's make this bigger. This can be something like, let's give it a name first, by the way. So we have a key and we have contents. What do we usually call the other thing when we call something a key? We call it a key and a, I don't remember. Let's call it content for the time being. So let's see, content, and this should be 256. And I don't think we need anything else here. Perhaps we need some kind of ID. Header could also have a, that's interesting. Arnav says, header could also have its own content, a content length. You mean like that? Okay. Do you mean that a content length thing is part of the HTTP standard, or do you mean like I should use it to keep track on just the length of the thing? Ah, you mean like, okay. I thought we, okay. Yeah, that's entirely correct. We do need that, absolutely. Thank you. Let's see, where were we? So, let's see. We can basically use this for that, right? It should be the same. Alright, so we have those two, and maybe we should have some kind of ID number, but I'm not sure why we would need that. So let's leave it out for the time being. And are we going to store the headers as an array, or shall we store it as a linked list of some sort? We will not be going to rearrange it, the order. But if we remove something But we're not going to do that either, right? We will just present it to the user. So I think we will go with an array for this one. And let's typedef this as well. So we do struct as header, and we will call this header with a capital H. And we'll move right on to the cookie. And what does the cookie contain? There are a couple of things, if I remember correctly. First of all, we have a key here as well. And we do, of course, have the content. What else? We do also need, there is some kind of expire date, right? How shall we store an expire date? We can have a Unix timestamp. And for you who doesn't know what a Unix timestamp is, it measures the, how do you spell that? Measures the total number of seconds from one agreed upon date. I think it is something like 1st of January 1970 or 1980 or something like that. And that makes it very easy for programmers to handle time, which is regularly a very advanced topic. Thank you, Arnav. Alright, so let's see. Let's just do int 64 timestamp. What else does this contain? There are some kind of access level things, like if you can reach outside of the domain or not, and stuff like that. But I'm not sure if we need any of that, to be honest. Hello, Jose. Look to the left of your screen. You should be able to see the type of project, the constraint, and the language. But basically we are coding a fetch library. Maybe I should be more expressive on this one. It's a fetch library. Something like this. Okay, it's an HTTP fetch library for C. Also whether the cookie is secure. That's right. Good. We need to define if it's secure or not. That's something we should put in there. So that will basically be a Boolean. And Booleans, do we have Booleans? Is that a part of the library or the language? What do we think? There is an include, which is called something like std bool. Where is it? Let's search for it. It should be called std bool.h. Okay. If it's inside of the C++. Maybe it is because it's not a part of the... I think it might still be an extension to C in this version that I'm running. But it is a part of the standard by now. So TRL C std bool. TRL C std bool. Okay, so there's one for C and one for C++. Okay, I don't find the C std bool. Is it a directory or... Okay, its name was just without the .h. That must be some weird C++ stuff. Okay, so let's see. Include stdbool.age. Okay, so now it becomes some kind of a loop right here. Never mind. It's not a very difficult thing to define. We can do it on our own very easily. It was just interesting to figure it out, you know. Okay, so is the cookie secure? Yes or no? Okay, so let's define our booleans. So we'll have type def. Let's see. No, it will not. Yeah, it will. Type def unsigned char is the smallest thing we can accomplish, I think. Well, we could do some kind of a structure and alter the bits part of it, but that would be very difficult to work with because we always need to do point thing. Maybe I should show what I mean. If we, for example, were to do this, we would do a struct as bool. Then we need to put something in here, right? Which would probably be an unsigned char bool, 1 bit wide. And then we would do a type def struct as bool to bool. The problem is if we create a bool x, we cannot just do this. All the time we would have to do x dot bool equals true, which would be rather tedious after a while, right? The alternative, which I am choosing in this case, is wasting 7 bits and make this an 8-bit structure, like so. And then we will just do define true 1, define false 0. Now we have booleans, ladies and gentlemen. Not very difficult. Alright, so we have key, we have content, we have timestamp, and we have the secure thing. What else? We have a question in the chat if we are reading the RFC in order to code that. Yes and no. I will be making a lot of it from my memory. I have written a lot of different HTTP clients and servers before, but I don't know the entire RFC by heart, not all the HTTP status codes and stuff like that. So at some point or another we will most definitely be looking at the RFC. And for those who don't know, an RFC is a request for comment. RFC is a document which defines things like a network protocol. So it's the source of truth for the HTTP protocol. And I just remembered we need one more thing. One very important thing, or two actually, but primarily one. We need the method, right? So the method, okay, the method is not that important when we're dealing with the response. Maybe we should leave that to the request. Right. Let's do that. And let's start writing the request. I never mentioned anything about that in the beginning, but of course we need to have a request as well. And that will also be a part of our API to present for the user. Let me just do the last step here. So struct s cookie will be cookie with capital C. All right. Let's create this thing. And let's try to keep it as brief as possible or as easy as possible. We do not want to put 100 things in here right now. But we do need to put the most important things in here. One being the URL. And I think we should create one type for that. Let's call that URL. And URL. And URL is the address, the HTTP, www, etc. That is the URL. And this should probably be a pointer, but I don't think it necessarily has to be. Let's keep it like this for now. So we need the URL and we need the HTTP method, which should also be its own type. Let's call this method. And what else do we send to the server? We will send cookies, perhaps. Which means we need to have one of those cookie arrays. And we will have headers as well. So same here. What else? Did we break out the content type? Yes, I think we did. Yeah. Shall we do the same here is the question. I think so. So we will have an int content type. And we don't really need to make this a pointer. We can make this a big array instead. Content type should be 256 or 255. 256. Okay, and we have data and size, so that we need to have as well, because we need to basically mirror all of this stuff. And we are going to send the content length if it's a like an HTTP post request. So we will use the size for that. And then we can have a whole lot of other different things. I don't think we should get too deep into this though, because then we will never be able to crawl us way out. Okey-dokes. So we'll do type def as quest, and it's a struct. And we will call this a request, like so. And let's see that we have everything in order. What do we reference here? We reference header and cookie, and those two we have above, because it needs to be defined before we go to the next one, so to speak. And then we have method and URL and those. So we need to define the method and the URL. Let's do that up here. So what is a URL? This will probably be a structure because it contains multiple things. So let's make this like so. And what does it contain? Well, if we look at it, we have, let's do an example. You can do my support page perhaps. Some sneaky commercial. So let's say we have this URL. What are the different parts? Well, we have this one. Everything before the colon is the protocol. It can be, it's usually HTTP or HTTPS, but it can be other protocols as well, like FTP and some other. So how shall we define that? I think I will define some kind of an enum for that. No, yeah, an enum. Because there are only a couple of options, like, right? So let's call that protocol, and we call this protocol as well. So this will be, I don't often do enums, I tend to forget the syntax every time, but I think it's something like enum e protocol, and then we should have this thing, and I never remember the order, but I think it's first the number and then the string, I think. And I can't remember if it should be in quotes, but I don't think so. So we have HTTP and we have HTTPS. This will be the only two that we support. So we'll type def this in protocol to protocol. Then we have this part. After the first slash to the next slash. Or after the two slashes to the next slash. We have the domain, right? The domain name. And that can be a regular int 8 pointer, which is a string. And we can make it an array. So let's say this is the domain and we have 256 bytes. No, that's too much. Let's do 128 because I will be handling this inside of a 256 byte total, which means we must have room for both. So that will be the domain, and then we have the possible thing at the end here. which is basically the file and folder structure on the server to the specific file in question. At least that is how it's designed to be. Nowadays, web developers often manufacture these things and call it routes instead. But let's think of it as a file. So let's put all of that inside of its own array, which we will just call file. Like so. And this is a URL. So we type def struct s URL to URL capital U, and we save. Alright. Do we have all our data types? I think there was one more thing somewhere which we haven't defined. Which am I thinking about? We did the method. We did the URL. We have cookies and headers. Maybe we have everything. And when you plan your project, how you should code it and in what steps and all that stuff, as I mentioned, now you might get a sense of why it's good to always begin with the types, data types. Because if we just look through the types right here, we can see basically a great big part of the domain business logic right here. We can basically say what this program does and how it does it just by looking at these couple of types. And that's how you want to structure your program, because then it will be very much easier to manage. Okay, so when we have the types, the only thing we have to do, the only thing inside of imaginary quotes, is create the functions which make use of these types. And that we will start in a little while. I want to take a look at the chat. So, what do you say, guys? How do you think the project is going this far? Is it structured the way you were wanting it, or what are your thoughts? Rust is bad. What's the difference in this method of typedef versus doing something like typedef struct? Problematic. There is no difference, but maybe you have noticed that I use the old way of coding C. I never define the contents of a variable on the same line as I create the variable. And in the same way, I don't define a data type on the same line as I create its contents. And that's basically because when I started coding C, that wasn't an option. You could only create variables at the very top of your function, and you could not do like int a equals 2 or something. You couldn't do that because you needed to break it up. And I learned C that way, and I keep coding C that way because I think it makes sense. It makes for very, very much cleaner code. You have all your variable definition at one place. It's very easy to find them, especially if you put them in alphabetic order. And when you define variables all over your code, it's a mess to find what kind of type it is and so on. And I use that same style for everything that I code. Even if I code a JavaScript or TypeScript, I always do a let x on one line, and then later on I do x equals something. You can programming an IMAP server or POP3 server. Yes, I can. An email server was actually a suggestion for tonight and an alternative in the vote, but the other guys voted for this project, so this is what it is. But I could for sure do an IMAP or a POP3 server later on. I don't know the POP3 protocol, to be honest, and I do know the IMAP protocol somewhat, but not the POP3, so I would have to read up on that. But I do know the SMTP by heart, at least. I'm new to your channel. How long have you been using C? I've been using C for 25 years. Almost exactly 25 years. And I've been teaching C professionally the last like 8 years. So yeah, I have done it quite a lot. Let's see if there is any question or anything I have missed. I don't think it is. Okay, it would be cool to follow you as you read the definitions of POP3 and implement, for example. I'm not sure it would, actually. I have been considering doing something like that, but I think it would be very boring for most of the viewers watching me read. I don't think that's very, what should we say, content friendly. But I would gladly read up on those protocols and make a server out of it. Alright, so we're halfway through the stream, a little past even. And as I usually do, I take a 20-minute break inside of the halfway through. So what I will put up a screen with a progress bar, and when it reaches the end, it has gone 20 minutes, and I hope you will all stay with me, because after the break I will do some very exciting stuff and create all of the functions which relates to this project. Alright, any idea on GUI libraries like Raylib? I don't know much about this SDL, SF, but Raylib looks like a really grade A code, to be honest. I think it's very, very impressive. Alright, see you in a bit. Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support. Okay guys, welcome back everyone. I am glad to see that everyone has seemed to be staying for the break. That I interpret that as you find this project to be interesting. I'm very glad. Thank you, Arnab. Hello, Prakhar Gupta. I remember you from my earlier streams and from the channel. Very welcome to the stream. Today we are coding an HTTP fetch library for C, similar to the one that's in JavaScript. And we are coding it with the constraint that we cannot use any libraries at all, except my own. So we will be coding everything from scratch. The only thing we can call is the operating system's own system calls. Alright, so let's continue with the project. Before the break, we defined all the necessary data structures, or most of them anyway, and set up the general logic of the program. Now we're going to develop the different functions, and the most important one being the actual network communication. And that's usually not much of a hassle, but since we cannot use the standard C library, we need to be a little smart about this. Let's see first if I'm still connected to my server. Yes, I am. Alright, so in order to be able to call system calls without the C library, because the C library uses wrapper functions for all the system calls. So if we, for example, check out the connect man page, so this thing here, it is a system call, but it's actually a C function called connect inside of the standard C library, which will call this system call inside of the Linux kernel. So we need to create our own version of this one. And we do not have these structures either, this sock address and socklen t in this case. So those we need to figure out how to do as well. And the first function we need to define is the socket function, because before we have a socket we can't do pretty much anything with the network. So let's see if we can create this thing. I'm gonna do something like this. I will create an own translation unit for the network communication things. So let's create a new file, and let's call that network.c, and this will be network.c. Let's call it networking without libc. That's a standard C library. And along with this, we will also need a header file, so network.h, and this will be network.h. And I will do a pragma once, so we can only include this h file once. Okay, so we need to update our Makefile in order to, let's see, in order to create network.o, we need to have a network.c and a network.h. We will run cc with our flags and -c and the first source file. When we have this .o file, we don't need to do another step, but we do need to reference it when we compile the thing. So like this. Right. Now we can close down the Makefile and try to create this networking stuff, with first being our socket function. So let's take a look at the signature of the C version. It returns an int, which is a file descriptor for the socket. It takes a domain parameter, a type parameter, and a protocol parameter. All of those are regular 32-bit ints. So let's follow this standard. We will create our int32 socket, and it takes an int32, what was the first one? Domain type protocol. So basically it will be 3 int32s. Or maybe we don't need them that big. There aren't. Let's do it like this. We need to mimic it as best we can, because it will be problematic when we send it to the operating system otherwise. Alright, so, okay, I'm in the wrong file. I meant to do this. So this is the signature. Inside of here we will include network.h, and we'll create this socket function. And we have domain, what is this called, family, and protocol. Let's double check. Type and protocol, okay. Like so. And how will we handle this? We will create a function which will be called system call. System call 3 for 3 arguments. And then we'll send our arguments as is. And we will simply return the same thing as this system call, but we will cast it to an int32. And we do all right. We can use our macros. So this will be cast to a 32-bit int. This will be a regular int, a regular int, and a regular int. Something like this. So far, so good. We need to define this system call 3 function as well. And how do we do that? Maybe we will just do something like void system call, because we need to be able to handle different kinds of return values. Or it will always return a 32-bit integer, actually. So let's do this. And then we will simply, here we need to do this though. So we will call this arg1 fix screen. You don't see? That's weird. It has frozen, alright? That's weird. I'm glad you told me. Let's see what happened here. Let me restart. Hang on, guys. Okay, now you should be able to see. I'm sorry, I don't know what happened. I must have lost network connectivity at one point, and then it froze. So let me just show you what I coded. I didn't got very far. I created two new files. This network.h, which simply has this socket function for now. And then I did it like this. I did a system call 3 for 3. Let me just think. Yeah. Maybe we don't need this function, by the way. We can probably just do system call. Right. Because we can include this system call 2 function. Let's see. Is it syscall? Yeah. Since this is inside of the operating system. So we can use that. So inside of network.h, we will have an include sys/syscall.h. And this makes it possible for us to do system calls. But it's not called system call, it's called syscall. And we need to specify the type of system call. So this will be, I think we write it like, either it's sys socket or it's num socket. Let's see what the man page says. Okay, it's this. So a system call, by the way, is a function which lives inside of the operating system. And we are calling it to do some tasks. And usually this is done behind the scenes by the standard C library, but since we can't use it, we will do this manually instead. And I think we can just do this. Let's try it out. So let's define an int32. Let's go with s for socket, and we do s equals socket. And the way I usually do this is I say af inet sock stream and a 0. But what is af inet and what is sock stream? That we need to find out by looking inside of the header files. So the easiest way is, let's see, if we go here and we go into the user include folder, we can use the grep-r. We paste this in and we put a dot right here, which means this is the directory we will start our search in. A dot means the current directory. And then we get a lot of different stuff. Maybe we should do an extended grep. Then we can use regular expressions, and we can put something like define, and then something, and then if inet. There we go. So it's defined as pf inet, okay? Then we do the same with pf inet. And here we see that it's 10. So let's go into our network.h and we define AFINet, and now I can finally do it in lowercase instead. I don't like uppercase, not even for constant definitions. And this will be 10. The next thing we need to define is sock stream, or lowercase. This right here. So we'll do the same. This time we'll search for sock stream, and that is defined as isn't this the same thing? That's weird. Let's check this file out. I will open it in the I, and I will search for sock stream inside of this file. Aha, it's an enum. Okay, so sock stream equals 1. Let's put it inside of our H file, and now we should be able to use our function like this, and we can echo out the result. Since I am allowed to use printf in debugging purposes, I will remove all the printfs later. So let's see. S. And we probably need to cast this back to an int. And then we return 0, something like this. Let's see if we can compile this thing. Let's do make clean and make. Okay, method is I knew there was one. And also it seems we did the enum wrong. I never seem to be able to remember in what order you put the arguments. Let's clean this off. And it's probably like this then. And then we need to define the method as well. This part. And the method that can also be an enum actually, because we don't have all that many different to choose between. So let's do an enum e method. And let's set let's begin with head, by the way, as 1, and get can be 2. We have a post. And what else do we get? We have a put and a delete. What else? There is something for updates. When you update one thing, patch. Alright, and then there are a whole lot of different other methods that no one ever uses. But I think these are the ones that people use. So let's type def this enum e method. should be method capital N. And we run make again, and okay, a new error, not the same as last time. That's an improvement, right? So let's see, where does it fail? Unknown type name int32. Alright, we need to, yes, what do we need to do? The int32 stuff is inside of our grab.h, and we do not want to include that from network.h, causing a loop, but we could include birchutils.h, my own library, because that contains all the different integer types. So we make clean, we jump down a little bit, we clear the screen, and we run make. Boom. Okay, it's not the same error. That's an improvement. What does it say? Conflicting types. From what? Aha, birchutils is including all the libraries, C library stuff. Okay, we can't do it that way. Let's instead just copy this code. So we have 1, 2, 3, 4, 5 lines. We delete, we paste, we go to network.h, and we paste it right in. Like so. We remove the birchutils from here, and we also need to remove it from our Makefile. And we have it here as well. Let's remove it from this. Now I think we should be okay. So we make clean, we jump down a little bit, we clear it screen, we run make, and boom. Okay, that's better. Implicit declaration. Okay, we went from too many declarations to too few. That's funny. Why is that? Right, we need to include our network.h here as well. Run make, and it's almost gone. I didn't rename those because I don't want to have a lot of capital letter things in my code. I think it's ugly and it's difficult to write. Alright, now I can almost guarantee that it will work. At least that it will compile. No? What did I forget? Some kind of character on line 4 in network C. I couldn't really anticipate that one. Okay, let's remove this thing. And let's go. Right, we don't have my macros either. So we have 1, 2, 3, 4, 5, 6 DD P, and we go to network H and we paste. Okay, now I think we fixed anything, and it's no problem that we run into all these different errors as long as we fix them quickly. It's those tough errors we need to watch out for. Okay, one left. Implicit declaration of syscall. Didn't we have that? Man to syscall. I thought it was defined in this. Maybe not. We need to check that out. So let's go into user include i3 and sys, and we open syscall.h. What do we have here? We have asm unistd and we have bits syscall.h. So let's begin with the bits syscall.h, and inside of here we have a couple of different things. Sysaccept number. Okay, we have mappings from the old naming standard to the new. And that's all. What else? We had asm unistd.h. And then we have that. Let's see. If we go into asm and we grep for syscall right here, do we get the definition? Or let's make an extended search for int syscall. There it is. No, to have type int even though syscall numbers. So where is it? Int syscall. It's not anywhere, it would seem. Or perhaps somewhere here. Anyone see it? Never mind. We do have the definitions and stuff, so the only thing we need is the signature. So let's just grab that from the man page instead. Here. So let's see, we go to our network.h and we will put it right here. We don't need that part. Okay, let's try again. We do make clean, jump down a little bit, clear the screen and run make. Boom. And there we go. Ladies and gentlemen, we have a executable. Let's see what it does. If we run this thing, we get a 3. That's correct. That's exactly what I was looking for. And if we run an strace -f, we see that we where is it? There. We successfully ran this socket command with the correct parameters. So our system works. Now we only need to do this for the other former libc functions that we need. And we're on our way, we're steadily on our way to write a fetch library in C without any dependencies. Okay then, let's continue this journey. What is the logical next step? When we have done the socket, the next thing we need to do is the connect system call. And it takes 3 arguments. It takes the file descriptor, this. It takes an object which contains the IP address, and the port number and address family and stuff like that. And we need the size of that object. So first of all, we need to figure out what format that object should be in, so we can mimic it correctly. And usually it's being cast from, to struct sock address star and the reference to it. And the variable type that we usually use is called struct sock address in. So this is a specific type for internet sockets, and this is the general type that the system call wants. Anyhow, we need to figure out how this is being, how this looks, basically. So how do we do that in an easy enough kind of way? Let's go into our header files again. So let's search. And what do we want to search for? Well, we want the struct sock address. And we probably don't want anything before the struct keyword, because otherwise we will get all the instances of it. We only want the declaration, right? Let's see. Okay, we did only get 3, that's good, and only 1 relevant. Bits socket.h. Here we go. Okay, so all it takes is this thing, SA date. Okay, it takes a sock address common thing, address family and length, address data. Perhaps it's more convenient to look at the inet version directly instead. What if we were to do struct sock address in? Then we get nothing. If we do it one step above us, then we get some stuff. Alright, so let's see which looks promising. I would say this one. Sock address in. Okay, so this is the right thing. Let's copy this. We're not going to copy it as is, but we do, however, need it for reference. So let's see. out so well. Can we do... No. It's annoying with these comments right here. Well, let's just remove all the comments. Port number, remove that. Pad the size of struct sock address. Okay. Alright, now we go. So what do we have? We have the sin family, whatever the kernel SA family T is, probably something like a char or an int, I would say. Then we have the sin port, which is a BE16. I suppose it's the same thing as my int16. Then we have struct in address and sin address. And if I remember correctly, there are two things in an in address. We need to figure that out. And then we have the padding, and we need to calculate that somehow. Is it possible to? Yes. Okay, so let's create our own version of this. It's a struct s, what should we call it? Let's just call it sock address. And we need some kind of an int structure. Int x, we don't know how big yet, and that is the, let's just call it family, and we need an int 16 for the port number. Then we need an in address for the address, and we need to define an in address, and then we need some padding. So let's say int 8 padding and some number. We need to calculate how much, because why do we need padding? Because this is basically not the same as the sock address structure the operating system wants. This is a sock address in structure, which is a deviation from it. So we need to fill in all the blanks, since sock address is probably a bigger structure then. And we will just fill it up with 0 bytes or something. But we do, however, know, one needs to know how many. Alright, so we will make a type def for this. So type def struct sock s sock address, and our sock address we will just call sock address like this. Alright, now we need to do the same for the in address. So we need to create an in address structure with something here, and let's type define this as struct s in address, and we call it like this. And we need to find out what to put in there, right? So maybe it's even in the same file. Let's search for let's see. The line should begin with struct in address, or at least struct and then something in address. And here we go. This was pretty easy. So it's just a 32-bit IP address. That's all. Why do we need that inside of a structure? If it's only one thing. Why do we need that like this? That's really weird, huh? Is this really the correct one? Let's do a search for in address. We do have one more inside of net inet. No, it's the same. If anyone in the chat has an idea why they put this inside of an empty structure, please do tell. Meanwhile, I will not do it like that. At least I will try not doing it first. So let's just define this in address to be unsigned int, because that's basically what it is, right? So address will be an unsigned int. Okay. Now we need to figure out this padding part. How much padding should we put there? So what is this formula? We have something called the sock size, and we subtract 2 bytes, the size of short int, and then we subtract 2 bytes more, and finally we subtract 4. So we remove 8 bytes from this sock size, whatever that is. Let's find out. So we do an extended grep, and the line should begin by define, then something, and then this. Not V, we should have R here. Okay, we got a match. This looks more like it, I think. And the sock size is 16. So 16 minus 8 is 8, right? Which means we will have 8 bytes of padding. If I have calculated this correctly, but I think I have. So something like this. And let's remove this comment. And let's create a structure like this. So So we need an, let's see, maybe we don't need to be this, yeah, let's be. I was thinking maybe we shouldn't even have this in address, maybe we should just put an int here. But in address is being used in other occasions on its own, so let's keep it. Alright, so let's create a sock address structure, and let's set the sock, let's set, okay, this should not be there. Let's set the sock family to AFINet. We already have that constant. Let's set the sock port to some function f of 80. And what is this function f? Well, we need something to put this into network byte order, since usually we would do age to ns, but we don't have that since we don't have the standard C library, so we need to create our own function for this. And then we will have the sock address, which should be equal to some function g of an IP address. So what should we use in our example? I don't want to add DNS resolution and stuff like that for now. I will do it later. But let's see. Maybe we can grab the repo or something. Let me see that it's accessible through this. So repo.verge.com. Okay, we don't have curl. Let's install curl. It's a quick operation. Curl is a console-based HTTP client, by the way. Just a couple of more seconds and there we go. Alright, so let's curl this thing. Can we reach it? That is the question. Maybe it's only reachable via HTTPS. And maybe I can't reach it at all through this firewall that I'm behind. Never mind. Let's go to Google. That should be possible, I think. Yes. Alright, so let's resolve www.google.com, and we grab the IPv4 address like so, and we put it inside of here as a string. When we have function f and function g is basically the same as f, but it takes a IP address in a dotted decimal form, which this is, and it turns it into an integer in the network byte order. Okay, so when we have those, we may, let's see, the socket we want first. And then we do this. Then we will do connect. And we send our S. We do struct sock address star. And we send our sock. And we send the size of struct sock address. So this is what we want to do. Let's create some kind of return value. Okay, so we need to create a wrapper for this one as well. So let's go to the main page and copy this signature. And inside of the H file, we will make our version of this. So we have in32 connect, and then we have in32s. We have sock address. Don't need to give them names. We have sock address, and we have let's say int h to cover it. Alright, and if we do it this way, we don't need all these casting and stuff. We can just do this. And we can't do this in in32, I think. Yeah, we can. We can handle it a little bit differently. Maybe we should do that for this socket as well, by the way. Let's let them return. Well, in this case, we do need an in32 since it's a file descriptor and they can grow pretty large. In this case, however, we only need a very, very small return value. So let's do it in int8. And we need to fix one thing inside of here. I will create, let's see, we want to return them in 32. And let's call this ret. And let's also have an int, assigned int x. Because if we get an error, that's probably going to be -1. And we don't get it if we have an unsigned int. So let's do this instead. We set x equal to this syscall. If x is less than 0, we set, let's do a ternary instead. We will set the ret equal to, if x is less than 0, we will set it to 0. Otherwise, we will set it to x. And then we return ret. So basically any error will get the -1 most probably, and then we will set this to 0 and return it. Otherwise we will return the actual thing if it's positive or 0. That way we can still use our own data types, but we still grab the potential error code. Okay, so we need to think similarly when we do this connect thing. So we will define the connect as an int8 connect. Or actually, we can make it a bool. The only thing we're interested in, did it connect or not? And we will have an int32s. We will have a sock address sock, and we will have int16 size. We will create an int8 ret and assign int x. We set x equal to we set x equal to syscall sysconnect. First argument we just send s, but we cast it to an int. For the sock address we need to cast it to sock address star, and for the size we should also cast it to an int size. And we set the ret variable to is x less than 0. Then we will set it to 0, otherwise to x, and we return ret. Okay, I think that would be it. Right, it should not be an int8 by the way, this should be a bool. So if it's less than 0, we will set it to false, otherwise true. Right. Now I think we can do our connect actually. Let's see if we can. No, we cannot, by the way. We still need those network byte order thingies. But everything else should be ready. Let's see if you can compile this. We will get an error with regards to the symbols of F and G, but let's at least fix everything else. So we clean this up, and we run make. Right. We need to find out what the x should be inside of int x. And as soon, by the way, as we have dealt with those errors, we will probably end it for today. We have just a couple of minutes left of the time. So let's see, where were we? Right, this structure. We never found out what the family should be. We just said int x. We need to figure that out. So if we go back to our includes and we make an extended grep for struct sock address, let's do was more than I was hoping for. Struct sock address. What did we do differently this time? Maybe we should run here. Right. Alright, so let's see. We go to this and we do struct. We do struct. No. Socket or storage. Did we go to the wrong one? So, okay, we probably did. Okay, now we're back here. So, the family, right, we should do it for the init part. So, sock address in, and then we get to this one, and we search for struct sock address in, and here we go. Alright, so the family is the only thing we are unsure about, and we need to find out that the kernel SA family T is. First, perhaps we should check the manual page. Sometimes we do get a match, but not in this case though. So let's search for it. And we got a couple of responses. But we want to find the definition, nothing else. So we look for define, and then this. And we don't get a match. Let's see, what do we get here? Perhaps we can just skim through and see where it's defined. It's a little bit tricky to find those things when, oh, what is this? Yeah, no, that's not it. If anyone sees, okay, here, type def, unsigned short int, alright, it's a 2-byte structure. So let's change this to int 16 and we are complete. So we make jump down, make, and what it's saying. Okay, it doesn't know what int 16 is because I need to put those on top. Alright, let's try this again. A little bit better. It complains of F and G. We expected that. Invalid application of size of. Because it doesn't know what the sock address is, that makes sense. And incompatible type. Yeah, it should be a pointer. So let's see. Connect should have a sock address star. That's one thing. And the other was, let's say, let's see. Yeah, we don't know what sock address is. We need to do. No, we can do this. Now what? F and G, we expected that. Variable ret set, but not used. Okay, it doesn't know bool. It's a little bit tricky when we need to define all our own stuff, but eventually we always get through. So we need to put this inside of here. And where should that be? Perhaps something like this. We need to make everything look nice. Okay, now we should get rid of at least 100 errors. Still a couple left. Now, conflicting types for connect. Didn't we make it a pointer in the other end? Probably not. Pointer here, sock address star. We'll connect sock address star. And this and that. Ret is equal to this, ret is equal to that. In here. Are we still connected to the server? Yes. Why did it complain this time? Let's check that again. Conflicting types for connect. I have bool in 32, sock address star in 16, and the other one is unsigned int. Why does it have that? Did I not remove the example? Yes. Where does it come from? In file included from network.c at the second line. Okay, it's network.h. In function connect, so there's undeclared. Okay, it's not complaining about the declaration of connect. It's just reference that file for this error, right? Sock address undeclared. Right, how can we cast something into something we don't have? And why do we need to? We don't, right? So let's just send this as is. Okay, that's better. F and G, and we have one more error left. Conflicting types for connected. We do have that still. Bool. It's the return value. I was focusing on the argument, but it's the return value it's complaining about. Because here we have in 8, it should be bool, right? Clean, we jump down a little bit, we clear the screen, and boom. Now it's only in 32S, in 32. Sockadder star, sockadder star. In 16. So one more time, we do clean, we jump down, we clear, and we make. Okay, so it's complaining that ret is an unused variable. Never mind. And then we have the f function and the g function left to define. And that's an easy enough task, since we know how to do the binary bitwise operations since my video from a couple of days ago. Okay, what do you think, guys, this far? Have you been able to follow along? Am I explaining enough, or should I put more time into the explanation stuff, or into the coding stuff, or what do you think? So, what have you discussed in here? Really cool for me, I'm new to this and I really want to learn. Alright, Ricardo, I'm glad to hear it, and welcome to this stream on my channel. Thank you. I'm glad to hear it. So, what else have I missed? Great, Arnab, you are keeping it up to date and answering the questions. That's great, thank you. All right, I think it's time to sum up this day. Today we have learned how to define our own wrapper functions for system calls when we are unable to use the libraries. And we have defined our domain or business logic by defining a lot of different data types, planning our project. We have also started coding a little bit on the network connection functions. And so far everything has worked as we expected after some quick troubleshooting. And that's basically it. Next time we work on this project, we will continue with the network connection stuff, and we will be able to do a TCP connection to the remote server, obtain all the necessary data, etc. So, before we end, do you have any questions or comments or anything? Please don't forget to like and subscribe if you like this episode and want to get a notification when I create new stuff, which happens very regularly, almost every 4th day. Okay, if it aren't any more questions, I want to thank you for being here today, and I'm very glad that we got so many. And also thank you, Arnav, for an excellent job on keeping track with everything. So, thanks for watching, guys, and thanks for today.